tutorial once again. In this tutorial, we shall be looking at introduction to differential equations, that is ordinary differential equations. And then we will start our study of differential equations in the same way the pioneers in this field did. We shall show particular techniques to solve particular types of first order differential equations. We shall be looking at linear equations, separable equations, Euler homogeneous equations, and exact equations as we take through the series. So stay tuned and go through the videos I'll be putting on in this playlist. We will also be looking at the power series and the Frobenius series as we proceed and we go deep and deep inside. Alright, so without much ado, we want to take the first order differential equations by proving its general formula. So we will take an example of a question and we'll use that to deal with this differential equations. That is Math 405, linear differential equation. So let's prove the formula, and that will help us into understanding it more when we are going deep into it. Now, this is a question given to us. The question says that given the constant a, b, which all belongs to the real numbers, where a is not equal to 0, we have y prime equal to ay plus b, which is the general formula of the linear differential equation of the first order, because differentiate is only one differential, so it's power 1. Therefore, we shall prove that y of t is equal to c e exponent at minus b over a when b is equal to 0. And this is our first example. And we'll also look at when b is not equal to 0 rather. So first we'll look at when b is equal to 0, and we prove the formula when b is not equal to 0. And then we will show that the initial values problem y prime is equal to ay plus b is giving us y of t naught is equal to y naught. That is, when we are talking about the initial value problem, it means that they have given us some unique values to substitute inside. Okay, maybe they've given us that t is equal to 3, 4, or any other constant, and then they've given us y to also be another value. So we substitute inside and we solve. So with that, we shall prove it using variables, and at the end of the day, we will be using numbers and solving real questions for our understanding to be perfect. So without much ado, let's take the first example and solve it. That's the I. From the I, we get the solution. Given y prime to be equal to a y plus b, if b is equal to 0, then it means that y prime is equal to a y. Okay, so divide through by y. I'll have y prime over y equal to a. Take the limit of the absolute value of y. I'll have this prime is equal to a. Why am I taking the prime? Remember, when I differentiate the limit of y, I'm going to get y prime over x, or sort over y. Example, let's say we know that lim of x is equal to 1 over x. That is, differentiate what is inside the bracket, which is 1. Differential of x is 1 over what is inside, so we get x. In the same vein, when I have the lim of y is equal to, when I differentiate y, I have y prime over y. That is why we are taking the lim here, so that when I it is just like I'm taking the same thing in the first step I just did. Now we are looking for y. We want to make y the subject. We don't want y prime. Therefore, we take the integral of both sides. When I integrate, lim of this is equal to integral of a respect to t. Now, integral of lim y prime is going to give me y lim y, because the integral sign is going to go with the differential sign over there, leaving lim y. And this is equal to differential of a with respect to t will give me a t plus a particular or a certain constant c. Okay. Now we want to eliminate the lim. We don't want this, so I take e on both sides. So I have e exponent a t plus c, and then e exponent lim will give me only y to be equal to e exponent a t multiplying by e exponent c. Now the laws of indices is that when I have a, so a exponent n plus n m the same as a exponent m times a exponent m. That's how come we can separate this. Now y is equal to e exponent c is still a constant, so therefore I can just multiply as c, that's a constant, exponent et, and this is finally equal to c e exponent t minus b over a, since b is equal to 0. Okay, since b is equal to 0, that is your first one is being what proved when b is equal to 0. Now we consider it. The next example says that when b is not equal to 0, so if I have y prime to be equal to a y plus b, when b is not equal to 0, therefore b cannot be eliminated, so I make sure that I factorize a in the right hand side out. So I have y prime to equal to a. I'm factorizing it out, and since I'm factorizing it out, I will have b over a, such that when I send the a back inside, the a is going to cancel the a on with the b, and I'll get only what? B. Now this is what we have. I can decide to add 0 to the left hand side. Adding 0 means I'm just adding something like b over a all prime is equal to b over a. Now b over a is a constant, so when you differentiate a constant you get 0, so you have added 0 to it. It doesn't make any difference. Now let me factorize the whole thing, and that will give me b over a all prime is equal to y plus b over a. Now this we illustrate. Let m to be equal to y plus b over a. Then we can say that m prime is equal to am dividing through by m. So I have m prime over m to be equal to a. Likewise, in the first example we did, so I take the absolute value of lim of that, which is equal to a. Now take the integral on both sides. is equal to A respect to t. And finally, I have lim of m plus, that is equal to at plus a certain constant. Now take e on both sides. Plus c, and this is going to be equal to m e exponent t dot e c. But I know my m is equal to what? Y plus b over a. So I replace it. Y plus b over a is equal to c exponent at. Since e exponent c is a constant, so I just replace all by what? C. And now you group like terms. So y is equal to c exponent a t. B over a on the left hand side going across will be negative b over a. And that also what? Proved when b is not equal to 0. So when b is not equal to 0, that is the proof also. Now it goes further to say that we should find the initial value problem. We should find the initial value problem. That is when t is equal to t naught and then y is equal to y naught. So we have to apply that. Recall y is equal to c exponent at minus b over a. We are looking for the value of c. So we know that where y of t naught is equal to y naught, so I substitute inside. So wherever I see t, I put t naught. So my y of t naught is equal to c exponent a t naught, okay, minus b over a. I'm looking for c, so therefore I group what? Like terms. Now c exponent a t naught is equal to y naught plus b over a, which implies that c is equal to y naught plus b over a, dividing by, so if I divide both sides by e exponent at, means that I'm going to get e exponent at naught, negative of that, okay, and this is c. Now we say equation 1, we substitute equation 1 into the original equation, because we have looked for the value of c so that it becomes a particular solution but not what? A general solution. So y equal to c e exponent at minus b over a is a general solution. Now when they give you the initial value problem or values, it means that you are going to find the value of c and put it inside. So c is now known. It means that that function you are going to get, or that solution you are going to get, is now a particular solution. So that's why we have found c using the variable t naught and y naught. Now we go and substitute back inside the original equation. So I have y to now be equal to c, and c is y naught plus b over a e exponent a naught, so at naught, and all is multiplying by e exponent a t minus b over a. Okay, now I sent in the e exponent t, so I now have y to be equal to y naught plus b over a e exponent a t minus a t naught minus b over a. Finally, my y will be equal to y naught plus b over a e exponent. So the a is common over there, so I can factorize the a out. So in factorizing the a out, I have t minus t naught, and that is all subtracting what? B over a. Hence proved. So it has been proved, and that is the last part of the question. Don't forget to like, share, and subscribe to the channel so that we will study mathematics together. Thank you for watching.